Good morning, students. We will continue our discussion of stack data structure. So, in the last class, we talked about the representation of stack, the normal representation of stack, and what consists of a stack, and what are the various operations we can perform on stack. So, a quick revision. Stack consists of generally two variable item. One is an array and another one is a pointer, that is called top. The top points to the topmost element of the stack. Since stack is a LIFO database, that is the last put in data is accessible at the very beginning. Okay, we cannot access the lower data without accessing the topmost data. So through top we always access the topmost data. Top maintains the position of the topmost data item in the stack, and the data item are stored in an array. So stack is a data structure. It is a structure which consists of an array and a top pointer. Okay. So that was all we did, and we also discussed about two operations that can maintain that LIFO structure. For retrieving the element, we use the operation called pop, and for putting the elements into the stack, we perform the operation called push. Okay. So there are two operations. One is pop, another one is push. Okay. So we will discuss the entire code of push pop and how to implement the stack in C language. Okay. So first of all, let's do this using an array. Actually, there is multiple ways of implementing a stack. You can implement a stack using an array. You can also implement a stack using linked list. Since we haven't studied linked list yet, so I am not going into that part. Once we study linked list, we will further see how a stack can be implemented using linked list. Okay. So first let's see how to implement stack using an array. So first of all we have to define the stack. So the program start as stdio.h and we will start with main. Now after the main function we have to take an integer called simply top, which is initialized to -1. See, this means the stack is empty. Empty stack. After that we have to simply define an array. Suppose I can say the array name is size. Okay. I will give it 10. Suppose. So this is what the array looks like. Now we have to implement this function. 1 to push pop. 3 what? We have to check whether it's full. And we have to check whether it's empty. We have to check whether the stack is empty or full, because if it is empty then we cannot pop elements out of the stack. Okay. Similarly, we have to check whether it's full. If it is full, we cannot push new elements into the stack. Okay. So for that matter, we have to also define all this function. Okay. So these are the more or less 4 functions we can implement, and we can also implement, like, it depends what you want out of the stack. Suppose you want, it is asked to display all elements. You can also put the logic of display in one function as well, called display. You can name it as function name is display, and you define the logic inside it if you want to print. If at all you want to print all the elements of the stack. So let's keep it simple now. We will define all these 4 functions. Okay. So now we have to check first of all whether it is full or not. Okay. So for full, how to just think when the stack is full? When the topmost element is the 10th element, isn't it? Sorry, the 9th element. Okay. If top points to 9, if top value is 9, index is 9, we can say that it is full. Okay. So we will equal to 9, we say we can print stack overflow. Are you getting it? Else, if top is 9, print a stack overflow, return 1. Return 1 means yes, it is true. Okay? Because we are giving an integer return value. So whenever it is integer return value, you have to return 1 for true. Okay? So it is 1. Else return 0. Else return 0. Return 0 means false. That is, yeah, no, it is not full. Okay? So we can also type the return as boolean full, because boolean will take true or false. We can just simply say return true true. Else, in an else case, we can simply return false. Okay? So when top is 9, that means yes, the stack is full, so we have to return 1. Okay? So this is the logic of bracket close. This was the definition of is full function. Similarly, we will define is empty function. Whether the stack is empty or not, the logic inside it will decide. So let's write the logic for this. Int empty. So yes, argument we have to take stack. Which one we are checking whether empty or not? We have to, sorry, no argument. Int empty. Now for empty, what we have to do is we have to see whether top is -1. If top is -1, what is the logic of empty? When is the stack empty? When top is -1, that is no element is present inside the stack, then we say stack is empty. So we will just write the logic. If top is equal to -1, printf stack empty or underflow, whatever you will write as per your wish, and return 1. If the stack is not empty, we say return 0. So this was the logic for to check whether the stack is empty or not. Okay? So you will note it down, you will take a screenshot of this and you will practice later. Just remember that this is important. These two logics are important. Then I will rub it down and I will further write the logic for push and pop. Okay? Which requires these functions. Full and empty is required by these functions called pop and push. Okay? In pop, we have to use empty, function empty, and for push we have to use full, because we can only push element only if it is not full. If stack is already full, we cannot push element. So that's why to check whether we can push element into it or not, we have to use these functions. Similarly, for popping element, first we need to know whether it is already empty or not. If it is already empty, we cannot pop. Okay, because there is no element, how to pop? So to check whether it is empty or not, whether we can pop element or not, we have to make use of empty function. Okay, so just make a note of it. I will run it down. So let's see the function called push. Okay. So write push. So for pushing, we need an element to push, right? We have to push some element into the stack. So that element is passed in the argument itself. Okay. Suppose the element is int x. This is the element we want to push. We have to push element x. So what we will do? First we will check if full printf push cannot be performed. Push can't be performed. If stack is already full, we cannot push element into the stack. Okay? Otherwise, else, we will simply put the element. How to put the element? First, we have to increment the top variable, and at the top position, we have to put this variable. Okay? Else top plus plus and size top is equal to x. Okay, assign x in the topmost position. Simple. The logic is pretty simple. I hope you have understood the logic of push. What happens is we have to push element x. So before pushing the element x, we have to check whether the stack is already full or not. So we will check the full function whether it is returning 0 or 1. If it is 0, that means it is not full. We can increase the top, and at the topmost position we can put the variable x. Okay. If it is not full, if it returns 1, if it is full, if it returns 1, then push cannot be performed. Okay. If it returns 1, if that is the stack is full, that is true. If indeed the stack is full, then push cannot be performed. If it returns false, then we can perform the push operation. It will go to the else part, since if part is false, so it is not full, so top will be incremented and we will push the element into the topmost position. Okay, I hope you understood it. I have clearly said everything multiple times. Okay, now we will see how to implement the pop function. Okay. So what happens in the pop case? In pop case, we have to get the topmost element, okay, decrement the top variable, and then we have to return the element because we need the topmost element. Okay. So what happens is, in case of pop, we have to check before popping whether the stack is already empty or not. Okay. Excuse me. If the stack is already empty, we cannot perform pop operation because there is no element to it. Okay, so let's see pop. What happens? First we have to check if empty, then printf cannot perform pop. It cannot perform pop. Else, if it is not empty, then we can perform the pop operation. For that matter, what we have to do? We have to get the topmost element. So, return, we will just take a integer variable, okay? Int 10. What will 10 get? 10 will get the topmost element, that is size top. Okay, we got the element in 10. Then we have to decrement the top. Top minus minus. Then what we have to do? We have to return 10. That is the element, the topmost element we have to return. Okay. So this is not void pop, this is int pop because we are getting an integer element. Okay, the return type and the return, whatever we are returning, must be of same type. Okay, that we have studied already. So this is about pop. So what we are doing here? We are checking first whether it is empty or not. If it is empty, then it will return 1, and once it returns 1, the if condition will be true, and we will print can't perform pop. Because it is already empty, we do condition where the topmost element will be stored in temp. We will decrement the top pointer, sorry, top variable, and then we will simply return the temp variable because this is what we wanted. Pop always gives an element out of the stack, that is the topmost element out of the stack. Okay, so I hope you got it. These were the four important functions: full, empty, pop, push, off, stack. These four functions are very, very important. Okay, without doing this, you cannot implement a stack. Okay, so I hope everything is clear to you. Now, if you have any doubt, you can post it in the comment section, or you can directly contact me through WhatsApp. You can even email me. Okay, so that's for all. In the next class, we will talk about how to apply stack on problems. What are the real life problems? We have polished notations, prefix, postfix notation for which we use stack. What are these notations? These are arithmetic notation through which computer performs the operations like multiplication, or when there are composite operation used. Suppose division, multiplication, plus, minus, there is a large equation. Okay, how to solve that? That is solved in computers through these polished notations. Okay, so there are two types of polished notation. We will study all about polished notation and how to solve those notation using stack. That is the application of stack. We will study in the next class. Okay, so this was it for today. We will continue with stack in the next class. Thank you.